In the previous video, we talked about the perimeter of the circle and we also derived the formula for it. Now in this video, we'll derive the formula to find the area of the circle. So without wasting any time, let's start the video. Now let me consider a circle. Now this circle has center as O and radius is R. Now moving x distance upwards from the center, let me consider a chord like this. Now again moving very small distance upwards, which is dx. Let me consider another chord. Now since this dx itself means that this length is almost tending to 0, it's very negligible length. So this portion out here will be considered as a rectangle. So if I ask you, what will be the area for this portion? You'll surely say the length into breadth. Since I'm considering it as a rectangle, why am I doing so? Because this dx length is very small, so that this curvature which you are seeing will not be considered as curvature part. It will become a line segment at this extent because dx is very small quantity. Now let us consider this length as L. So this full length will be twice of L. Now since this is perpendicular to the chord. Now area for the shaded portion. Since it is a rectangle, the area will be length into breadth. So what is its length? Length is 2L. And what is its breadth? It is dx. What we get here as 2L dx. Now, join this for a bit of time. We can simply calculate the L in terms of x and r by applying Pythagoras theorem. So let's do that. R square will be equal to x square plus L square. Now the value of L will be value of L square will be R square minus x square. Here comes the value of L, R square minus R square. Actually it will be like this, but since L can't be negative, therefore L will equal to R square minus x square. Now what is the area of the shaded portion? It becomes twice of under root R square minus x square dx. Okay, but we don't have to find the area of the shaded portion. We have to find the area for full circle. So how will we do that? We'll do this by integrating this small area, a small portions area, to get the area of the full circle. So now area of the full circle will be, as you can see, we'll integrate this area. Now what will be our limit? Since we know our integrating variable is x, we are integrating on the basis of x. So we'll put the limit of x only. So x will go from this point to this point. If we consider O as origin, this point becomes 0 comma minus r and this point becomes 0 comma r. So value of x varies from minus r to r. So our lower limit becomes minus r and our upper limit becomes r. So what we have to do now is find the area of the circle by calculating the derived expression. So area of the circle will become integration minus r to r twice of L under root, oops, there is no L, so twice of under root r square minus x square times dx.
Now this is very general and standard integrating expression. I'm sure you might be knowing how to solve this. So we'll move further. X upon 2 under root r square minus x square plus r square upon 2 sine inverse x upon r. Now here we have the lower limit as minus r and upper limit as r. So minus r to r. Now multiplying this 2 inside this bracket, we'll get x times under root r square minus x square plus r square sine inverse x upon r. Limit being same from minus r to r. Now by calculating this limit, we'll get, first we'll apply the upper limit, which gives us r under root r square minus r square plus r square sine inverse r upon r minus, now we'll apply the lower limit, which gives us minus r times under root r square minus r square plus r square sine inverse minus r upon r. So solving further, as we can see that this term evaluates to 0, similarly this also evaluates to 0. Now evaluating further, we'll get r square sine inverse 1 as r cancel each other minus r square sine inverse minus 1. Now evaluating further, we'll get r square into sine inverse is nothing but pi by 2. So r square into pi by 2 minus r square into minus pi by 2 this time, since it is minus 1. Now evaluating further, we'll get pi r square by 2 plus pi r square by 2. Now evaluating this expression further, ladies and gentlemen, we get the area for the circle.